Okay, so we are today going to talk about not rational numbers, but rational versus irrational numbers. And especially, we're going to talk about what the heck irrational numbers are. There are numbers in the universe that are irrational, not rational. But first, let's remember what rational numbers are. A rational number is any number that can be written as a fraction, like 2/3 or -1/111th, or any whole number, or decimals that can be turned into fractions. So a rational number would probably be a number that can't be written as a fraction, but we don't really know what kinds of numbers aren't fractionable. So let me show you. First of all, here's another rational number. Why? Because the square root of 64 is 8, because 8 times 8 makes 64. This square root also comes out rational. It comes out to 2, doesn't it? And what's the square root of 81? Well, it's 9, and 9 is perfectly rational as well, because all these whole numbers can be written as 8/1, 2/1, or 9/1. But what if we took a square root of a number, instead of like 36 that comes out rational, what about 37? What times what makes 37? Well, nothing times itself makes 37, of course. So, do we just say that there is no square root of 37? Or is there a square root of 37? There is a square root of 37. It's just not a rational number. And the only way to know what the actual square root of 37 is to use a scientific calculator that has a square root button. And I have one, and I punched it in, and this is what I got. It was a bunch of numbers that filled up the whole entire screen, and I know that means that it's a whole bunch of numbers that keep on going on and on and on. Except if I look carefully at all these digits, there's no pattern there. 6.082762530 It's not like there's the same numbers repeating over and over to where I can put a line over something. This is not a terminating decimal, nor is it a repeating decimal, and therefore this is an irrational number. An irrational number is a number that has decimals that keep on going and going and going and going forever without a repeating pattern. So if you've ever heard of the number pi, you might know that that is an irrational number as well, because it's 3.14 blah, 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 and it doesn't have any pattern or repetition. That makes it irrational. So here's your definition. An irrational number is any number that cannot be written as a fraction. Okay? In other words, it goes on and on and on forever with decimals that don't repeat. And it happens a lot when you try to take square roots of numbers that aren't squares of anything. Like 2 isn't anything squared, and 3 isn't anything squared, and 5 and 17 aren't any single nice rational number squared, so all of these square roots would come out irrational. So we deal with irrational numbers mostly when we deal with square roots. Okay? So is 121 square rooted going to give you a rational answer? No. I mean, yes, it's going to give you a rational number, not irrational, because 121 is 11 times 11. That's rational. But the square root of 2, it's not a nice rational number. It's irrational. So, first, I want you to try to make up a rational number. Then, I want you to try to make up an irrational number. And remember, we said irrational numbers usually happen when we try to take a square root of something that doesn't have a nice square root. Okay, so here are some examples that I made up. The square root of 4 is 2, and that's nice and rational. And the square root of 4/9, well, that's actually 2/3 times 2/3, and that's a ratio. That's actually rational. But the square root of 7 is yucky, because what times what makes 7? Well, you can't really do a square root of that, so that is irrational. The question, though, is how do you actually find the answer to see what the square root of 7 is? And of course, the only way to do that is with a calculator. specifically a scientific calculator that has a little square root button on it somewhere, even though that button might be hidden away and hard to find. It's there, and that's how you would actually calculate the square root of 7, is with a calculator to do the calculation. But sometimes we have to estimate irrational numbers, because what do you do if you don't have a calculator? What if you have to find an irrational square root, but you don't have a calculator with you? Well, we can make an estimation. Here's another irrational square root, because nothing times itself makes 10. So we don't know what the square root of 10 is. But we can estimate it. Even without a calculator, I can make a guess about the square root of 10, because I know that the square root of 9 does have a square root. Now, the square root of 11 doesn't, and the square root of 12 doesn't. And if you keep on counting up, though, you get to the square root of 16. 16 does have a square root, which is 4. 3 does have a square root, which is 3. And you might be wondering why the heck I'm doing all these square roots in a row. Well, it's because the square root of 9 is 3. The square root of 16 is 4. And the square root of 10 would have to be somewhere on the number line between those, right? It's a little bit more than the square root of 9, but it's less than the square root of 16. So it would have to go somewhere in between 3 and 4. But of course, do you think it's going to be exactly 3.5 right in the middle of those two numbers? No, because where is the square root of 10? It's actually closer to 9 than 16, right? So what would be a good estimate for the square root of 10? Not 3.5, but maybe something more like 3.1 or 3.2. Okay. Let's see if we can try that again. How about the square root of 5? It's a little bit less than the square root of 6, but that doesn't have a square root. And it's a little bit less than the square root of 7, and the square root of 8, and the square... Oh, okay. We finally found one that has a square root. That's 9, and the square root of 9 is 3. Oh, and if I go down one, the square root of 4 is 2. So where is the square root of 5 going to be? Right in between 2 and 3? No. It's closer to the 4, so it's actually not going to go up. It's going to go down. So probably not 2.5 or 2.6 or 2.7, probably more like 2.1 or maybe 2.2 or maybe even 2.3. Hopefully you see how to make a good estimate of an irrational square root. So now is your chance. You try finding an estimate for the square root of 24 and then see if you can find it on the number line. And if you're totally 100% lost about this, don't worry too much. We'll try it some more in class tomorrow. By the way, that shouldn't say practice problem number 1. I think this is like the 3rd or 4th practice problem, so sorry about that. Okay, that's all for today. Hope you enjoyed your introduction to irrational numbers, and we will explore irrationals more in class tomorrow.